Hello everyone, my name is Apasat Anuman and Dr. Bimuntip Singh, who is co-author. I am pleased to be here today to talk about petrochemical and engineering characteristics of columnar basalt in Buriram Volcanic terrain, Thailand. My presentation is divided into 5 main sections composed of introduction, geologic setting, methodology, result, and the last are discussion and conclusion. The Cenozoic basalts are distributed throughout Thailand such as Lampang, Kanchanaburi, Nakhon Ratchasima, Phetchabun, Chanthaburi, Srisakhet, and Buriram. Basalt in Buriram province erupted as lava flow in the late Cenozoic era, and its distinctive feature is the largest columnar in Thailand. This columnar basalt is an ancient famous destination for tourists. This basalt can also be developed as a geoheritage for educating local people and tourists to understand the geologic history and earth process in this area. In addition, basalt can be utilized in many construction and engineering industries. Although there are many studies about basalt in Buriram, there has not been much research describing the relationship between geology and geological engineering. This work will determine the origin of interesting basalt, both the columnar joint and plate joint linking with their engineering property. This aims to study the characteristics of petrography and geochemical of basalt, as well as study the strength of basalt with different joint characteristics. Right, let's move on to the study area. The study area has two areas which compose of Study Area 1 is Nang Rong Columnar Joint Volcanic at Bangkok Makharon, Sadao Subdistrict, Nang Rong District, and Study Area 2 is Nang Rong Silatong Active Colliery at Thawon Subdistrict, Cherlapakhet District, Buriram Province. There was a study on the characteristics of petrography, geochemistry, and strength of basalt with different joint characteristics, including columnar basalt and plate basalt. But in Study Area 2, we study only the characteristics of petrography and geochemistry. I will focus on the geologic setting of the study area. Field observations and literature reviews suggest that igneous rocks are found as Cenozoic basaltic rocks with dense vesicular texture, and some of them are amygdaloidal textures. This basalt flow over cold quartz formation, that is Cretaceous sedimentary rock of the Korat group. Geological structure in this area comprise flow, fault, and unconformity. I finished the second part and moved into the next one. The methodology was divided into 3 parts, include petrography, geochemistry, and engineering geology. The first part is petrography. 15 samples are collected from the study area for the petrographically study and photomicrograph analysis at the Department of Geotechnology, Khon Kaen University, for determining the name and texture of the study rocks. And the second part is geochemistry. The geochemistry of 6 select samples was studied by XRF at the Department of Geological Science, Chiang Mai University, for analyzing magic elements, while handheld XRF analyzed their trace elements at the Department of Geotechnology, Khon Kaen University. LOI was studied at Khon Kaen University. 2 interesting samples were selected for their rare earth elements. ICP-MS and ICP-OES analyzed them at the SGS-CSTC Standard Technical Service Company Limited in China. Above, we do the quantity of the various elements for classifying name, magma series, and tectonic setting that caused the study basalt erupted. The final part of methodology is engineering geology. This part consists of compressive strength converted from impact strength by Schmidt hammer. Testing in the field was carried out following ASTM D5873. The pilot strength analyzed for 20 columnar basalt samples and 20 petty basalt samples were carried out following ISRM test standard 1985 at the Department of Geotechnology, Konkan University, to compare the strength of columnar basalt and petty basalt. Right, let's move on to the result. This topic was divided into three parts, with the petrography, geochemistry, and engineering geology. This slide shows representative of the study basalt. The first picture is columnar basalt in study area 1. The next one is columnar basalt in study area 2. And the last is petty basalt in study area 1. The study rock can be determined as olivine basalt based on mineral composition. This basalt presents porphyritic texture, which olivine, cyanopyroxene, and plagioclase microphenolate. The ground mass of this olivine basalt consists mainly of plagioclase, with small amounts of olivine, cyanopyroxene, and opaque mineral. Olivine microphenolate are slightly altered to its side. Ground mass plagioclase showed tachytic texture, indicating this basalt erupted as lava flow. The geochemical analysis identified 6 select samples in the study area. Test diagrams were used to determine the spatial name, suggesting 2 samples of study area 2 or sample number 1AA and 2AA, and 1 of study area 1 or sample number 3AA were basaltic tachy andesite. 3 samples of the study area 1 consist of sample number 4AA, 5AA, and 6AA were basaltic andesite. Moreover, trace elements as zirconium/titanium relate niobium/yttrium determined that all samples were alkali basalt. The chemical comparison specifically focused on condinobrary pattern. Classify the origin magma series of the study rock correspond to the alkali series. In addition, this pattern shows the intersect of the plateau, indicate that the origin magma series of the study area 1 and study area 2 are different series. Additionally, the origin magma series by total alkali analysis determined that the study area 2 was the potassic magma series and study area 1 was sodic magma series. And the last part of geochemistry result, there are 3 ternary discombination diagrams were used to interpret the tectonic eruption of the study basalt. The trace element diagram brought titanium, zirconium, yttrium determined all samples were within plate alkali basalts, and niobium, zirconium, manganese determined all samples were within plate alkali. While the major oxide that consists of titanium dioxide, manganese oxide, phosphorus pentaoxide in the oceanic tectonic diagram classify all samples as oceanic island alkali or OIA. Therefore, port OIA field support the continental plate of Korat Plateau has been thinning during the Cenozoic and generate magma from mantle plume beneath the surface as hotspot. In another word, let evolute magma like oceanic crust. Let's move on to the engineering geology result. The impact strength test was performed as compressive strength and pilot strength index. The compressive strength of columnar basalt was 54.57 MPa. while petty basalt was 50.23 megapascal, which was 7.94% less than columnar basalt. The point load strength index of columnar basalt was 4.01 megapascal, higher than 23.81% of petty basalt, that was 3.06 megapascal. According to geological engineering analysis, columnar basalt have more strength than petty basalt by numerous data. Right. The last topic are discussion and conclusion. This topic was divided into two parts with petrography with geochemistry and engineering geology. Our study basalt sample are alkali basalt when indicating by trace element and its exhibit targeted texture, which indicate the study basalt erupt as lava flow on the Earth's surface. The origin magma of Buriram volcanic terrain is alkali. Nang Rong Columnar Joint Volcanic or Study Area 1 is alkali sodic magma series, while basalt in Nang Rong Sila Thong active quarry or Study Area 2 is alkali potassic magma series. These basalts were erupted within continental plates and exhibit oceanic Iceland basalt-like characteristics. Let's move to talk about the engineering characteristics. The columnar basalt has a compressive strength and point load strength index higher than the petty basalt, according to amount of eating site, which suggests weathering rate. Eating site 15.70 modal% in petty basalt and 10.06 modal% in columnar basalt, which is more than 5.63%. Possibly due to the surface of lava change temperature repeatedly, showing a crack and joint, while the temperature inside lava flow is relatively constant, making it characteristic of the soluble columnar joint. Thus, the microphenolkis was the primary source of crystallization and alter to eating site, appear abundantly in petty basalt 35.89%. In addition, the petrochemistry of study basalts support the significant indifferent characteristics were found to affect the strength of basalt, columnar basalt, and petty basalt. Thank you. Thank you all for listening. It was a pleasure to be here today.